to watch this to review for tomorrow because they couldn't make it right now, that's totally fine. Have them just go to the videos above. We'll get on this. Hey, AIDS. I'm in the class voice chat if you want to join me there if you've got questions. But without further ado, I'm going to get into this again. If you want to go to Google Classroom and grab this, I would encourage you to do so. What you should do is do this. Go here. Go to your review guide section under classwork. Click on this guy, part 1. This is what we're working on. As always, complete with answer key down at the bottom. First 3 questions are free response, so no answers for those. We'll be talking about that. So grab that and we'll get started. Let's see if I can make this even brighter. All my lights are messed up in here. I've turned them down a little bit. They've been giving me headaches. Trying to rearrange everything so that doesn't happen as much. Preparing for next year and the inevitable late start. All right, so explain. And diagrams are acceptable. The formula for the area of a parallelogram. So I'm going to draw a diagram of a parallelogram. Here's our parallelogram. It looks great. What I'm going to do is I'm going to show that, look, if I cut this little triangle off here, I can take that triangle and I can put it right here. I can take that triangle and slide it into this spot here, cutting along this pink line. Cut that out, and I can put it on the side here. And what I've got is a rectangle, right? So we have our height, which is this amount right here, right? And then our base is this guy, which is unchanged by adding on that triangle on the side. The base doesn't change, right? It's still the same length before and after. That triangle doesn't add on anything here. And so we have base times height. So our height is just going to be from here to here, right? Not the length of this diagonal or this diagonal, but perpendicularly down from here to here. And our base is just going to be the top part. So area of a parallelogram is going to equal base times height, just like a rectangle. Just our height's going to have to come from inside the object or from outside. You could draw the height here. 90-degree angle, totally fine, totally fine. Either way. So there's my explanation with a diagram. If you want to write words about how you can drop a perpendicular inside the trapezoid or outside the trapezoid, right, to the base, and that'll give you the height, that's fine. I think pictures are good enough for me. If you got any questions about that, let me know. Same thing we're going to do for a rhombus slash a kite. So I'm going to draw a rhombus. You could draw a kite if you want. I suppose this sort of does look like a kite if I'm not drawing it super accurately, but now I know that it's a kite or a rhombus because I've got all 4 sides congruent. So what I'm going to do here is I'm going to draw on the diagonals. Here's my first diagonal. This is a terribly drawn kite, or a rhombus, I should say. So here and here. And what I'm going to do is I'm going to take 2 of these triangles and I'm going to move them around a little bit. So let's color this one in light blue. And color this one in maybe green. And basically what I'm going to do is I'm going to rotate these around and complete the other side. Because this is a kite, I know that this side and this side are the same length, so if I were to flip these over, they would line up perfectly over the top of each other. And so what we're going to get is this. Let's see if I can make this happen. So we should have this the same. Right, I'm keeping this part the same. And what I'm going to do is I'm going to flip this over. And when I do that, what's going to happen is I'm going to get this. So we have blue, red, and a single tick mark, right? Blue, red, single tick mark. So that's our light blue side, or light blue triangle. And then our green triangle is down here at the bottom. Let me make sure I drew this correctly. Yep. So you'll notice that our diagonal 1 here, let's call that D1, is the same before and after. We didn't cut that diagonal at all. Let me zoom in a little bit. That length right there stayed the same here. We didn't cut it at all. But the red, diagonal 2, let's just call that D2, Mighty Ducks, this guy did get cut in half, right? Because these triangles moved over, so they deleted this red part here and then moved the red part to the top. So our red part got cut in half. So what this length is half of D2. Now, we know this is a rectangle now, or a parallelogram of sorts, right? At least that. And then we know that base times height is what we got to do. Well, our height is D1. And our base is D2 times a half. Now, I can do that in any order. I'm going to do D2 first, so D1 times D2. And then I'm going to times it by a half, which we all know is the same thing as dividing by 2. So either way works. You could write that, or you can write this. Either way. This is true for a rhombus or a kite. So again, what we're doing is we're just taking these shapes and we're just changing them by cutting them up into something we do know, right? A rectangle. And we know the area of a rectangle is the base times the height. Well, the base for this is a half D2, and the height is D1. So you times those together, and that's going to be your formula. Same thing here, right? If we move this over, we've got a rectangle. Our base didn't change. It was the same as before. And our height stayed the same as well. So it's just base times height. So half of one of the diagonals times the other diagonal is going to get your area. The next one is talking about the area of a trapezoid. This one's probably the hardest one. I think the first one's definitely the easiest. The second one's a little medium to figure out how the shapes go together, right? This one's probably the hardest one, but once you see it, it's not too bad. So let's take a look at it. So I'm going to draw a trapezoid. So maybe something like this. You can draw a trapezoid that has one leg sticking out and one leg going straight down. That's totally fine. You can also do it where both legs stick out. That's a terribly drawn trapezoid. All right, so we've got two different parts to this. We've got base 1 and base 2 going on here. So here's base 1, and here's base 2. Here, 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 here. And what we're going to do is we're going to find the middle of each of these two legs. So we're going to cut here, and we're going to cut here, and this is going to be the middle. So there's our middle there. Let's make this dot blue. And here's our middle there. And then we're going to connect the dots, which we're always allowed to do. I think I'll use light blue for this. There we go. So then I'm going to connect the dots. And what this is going to allow me to do is, for this side, since it goes straight down, I don't need to worry about it. But because this leg sticks out, I can draw a line straight down, and I can cut this little triangle off right here. And what I'm going to do is the same thing I did in the first diagram, is I'm going to take that little pink triangle and I'm going to flip it to complete the rectangle. And so what I'm going to do is I'm going to flip it above, actually. See how this side here matches this side here? So I should be able to flip it up here and have it perfectly overlap with this. So what I'm going to do is this. Let's see if I can draw this. This was pink from where we cut it. This. There we go. So I cut that pink triangle and I flipped it up to here. And then our blue dot here. So you'll notice that this blue line now is the same length as our top and bottom. Right? Our bases are now the same on the top and bottom. Before there was a small one and a big one, right? But when I flipped that up, it created equal bases on top and bottom. So whatever this is right here will be our new base. Now notice our height from before. Our height was really just this length right here, right? This is our height. Any straight line up and down, right, at a 90-degree angle, that's going to be our height. So I can draw it inside here at 90 if I want, anything like that. But that didn't change, right? It's two blues connected. And it's still two blues connected here. So our height's the same. Our bases are what changed. And the way we did that is what we did is we found the middle, the midpoint, right? The average between two things. And when we average stuff, we divide by the number of pieces, right? We add them up and divide by the number of pieces. So what we did is we took base 1 plus base 2. We added them up. And we found their average length. That's what that blue line represents, their average length. So our new length here is B1 plus B2 divided by 2. It's the average of our previous bases. The average of our previous bases. So now when we do math, right, we do the base times the height. Base is this, and we're timesing it by h. So the area of our trapezoid is going to be this times h. Now we can do that in any order we want. I'm going to do the h first. It's up to you. There you go. You could also write it like this. Times that h times both these guys. There's two terms there. So when I multiply, I have to wrap in parentheses. Write it like that. You can even distribute the h if you want. Doesn't matter. It's up to you. Right? The h goes to the b1. And then it also goes to the b2. You'll rarely see it like this because this requires more work. These two are the most common. So really what I want you to show is where does this part come from in the formula, right? Why do we do b1 plus b2 divided by 2? Well, it's because we're averaging base 2 and base 1 to get this length here. And the way we do that is we flip this up, and it becomes our new base, right? Our top and bottom is this blue line now. Should I go back and show you any of these questions on 1, 2, or 3? What I'm looking for? Again, you can stop after here. Any of those are okay. Feeling good. Zayden, how are you awake right now? Also, shout out to Abby Gembeck. What's up, Tucker? Yeah, regular geometry didn't really get to area formulas, which is unfortunate. We're doing proofs with quads, though. Can I go back one? Yeah, I can do that. So the idea is I took those two and I flipped them around here, right? We get this shape. Pictures, man. Number 1, Oh, 2, 1. Sorry, not go back 1. I missed a word there. This one's definitely the easiest once you see it, right? Cut a triangle here, which is your height, and then move it over. Getting emails. I'm going to start moving grades from classroom into the grade book. Again, only grades that would bring up your grade are going to go in, and that'll be for your final grade. Remember, your grades cannot be lower than what they were in third quarter. They can only go up. Most of you guys have done everything really well. Oh, wow. Okay. Thanks, Tucker. Sorry, Zayden. All right, let's take a look at these guys. So it says, find the area of each. All right, so this guy's our parallelogram. And it gives us a base right here of 7.3. So here's our base, 7.3. And they went outside the diagram. I mentioned that earlier, right? You can draw a line from top to bottom to do a 90-degree angle. But sometimes you have to go outside. Because if you look, if I start at the top here, even at this corner, if I draw straight down, right, it's not going to connect inside the diagram. So what they did is they said, forget it, I'll just drop from here to here. If this was a building, right, we'd measure the height of that building from the ground straight up, right? We wouldn't measure it at a diagonal, right? You never measure height at a diagonal, always measure it 90 degrees. So our height is going to be this guy right here. So we have a height of 5 miles and a base of 7.3 miles. Well, we know the area for a parallelogram is calculated by base times height, right? We move this triangle right here. We cut a little line, maybe move it over, something like that, right? So what we're going to do is do 5 times 7.3. So we have 5 miles times 7.3 miles. And that's going to give us the area. Well, first of all, miles times miles, anything times itself is itself squared, right? So 2 times 2 is 2 squared, 3 times 3 is 3 squared. Mr. Mac times Mr. Mac is Mr. Mac squared. Remember, I used to be a twin. Miles times miles is going to be miles squared. And that's where you get that, like, you know, feet squared, inches squared, whenever you do area, right? Then we have 5 times 7, which is 35. And 5 times 0.3. Well, 5 times 3 is 15. So 5 times 0.3 is 1.5. So we've got 35 and 1.5. 36.5. Bet you guys are all feeling pretty good about number 5. It's a square, right? Base times height. Go. Boom. Done. 7 centimeters times 8 centimeters is going to be centimeters squared. 7 times 8. If you don't know 7 times 8, maybe you know 8 times 8. 64, right? We need one less group of 8, so you take 8 from that, get 56. Or maybe you know 7 times 5 is 35, and 7 times 3 is 21. Add those together, 56. Either way, it's 56. 7 times 5 is 35. 7 times 3 is 21. Add those together. 56, right? 5 groups of 7, 3 groups of 7 is the same thing as 8 groups of 7. 56. How are we feeling about the first two? Gucci? Let me know if you need to go back. Since I can't see you in real time, and I know some of you guys are popping in and out. Totally fine. So to remember 6, this is our height, right? This is our orthogonal, right? From a vertex to the opposite side at 90 degrees, right? So our height is 2.9, and they gave us this length, which is 5 meters, they said. That's the whole base there. Again, this is why I like to make my own, but I was in a rush. So we've got this whole thing, which is going to be our base. Timesing that by 5 meters. Of course, that's going to be meters squared. Now, but that's not the whole formula, right? Area of a triangle, it's always half of some kind of rectangle, right? If I took that triangle and flipped it, I'd have it going over this way. I'd have a parallelogram, right? So this is half of that parallelogram, and the parallelogram's height would be 2.9, and the base would be 5. So what we got to do is we got to divide this by 2. Right? That would be the area of the parallelogram. When we divide by 2, we get the area of the triangle that would make that up. So we get 2.9 times 5, all divided by 2. Well, 2 times 5 is 10, right? And 0.9 times 5, well, 9 times 5 is 45, so 0.9 times 5 is 4.5. Supposed to divide that by 2. So it looks like that's 14.5 divided by 2. Well, what's half of a half? 0.25, right? A quarter. So we've got 7.25 meters squared. Again, if you want, answer keys here. 7.25 for our last one, right? Number 6. Check your work there. Number 7, same dumb thing. I'll leave that for you. Same dumb thing, right? It's a triangle. We have our height. We have our base. Height of 5.6 yards. Base of 8 yards. Go get them. Ocho. 8 and 9 are the same shape. They're both going to be trapezoids. Now we know the formula for a trapezoid is we want to average our bases, right? And then multiply them by the height. So here's our height. Our height is 1.8 kilometers. I'm going to times that by the average of our bases. Now, the average of our bases, the way we average something is we add them up and divide by the number of pieces, right? Well, we have base 1 and base 2, so we have 2 pieces. So we're going to add those up and divide by 2. So we're going to take 7 kilometers plus 2.6 kilometers. And we're going to divide that by 2. That's going to find us our average, which is going to be this line that goes from here to here. So what we're going to do is take 7 kilometers and 2.6 kilometers, add them up. Kilometers plus kilometers is kilometers. Right? If I add 5 feet to 10 feet, I'm going to get 15 feet, not 15 feet squared, right? We're just adding them up. 7 plus 2.6 is just going to be 9.6. When we divide that by 2, 9 divided by 2 is 4.5. 0.6 is 0.3, so 4.5 plus 0.3 is 4.8. Well, we know it's going to be kilometers squared, right? Kilometers times kilometers is kilometers squared. 1.8 times 4.8. How do you solve a problem like Maria? How would you go about doing that? Lots of ways to do it. I'm actually going to grab a separate sheet of paper. How do you solve a problem like Maria? This guy right here. How would you solve it? And if you want to join me over in the voice chat, you're more than welcome to. I'm muted over there, but I am there. Or you can type in the chat what you might do. What would be your strategy? Been a while since we've done one of these. I'll be back in just a second. I'm going to grab something to drink. You think about your strategy. Come back and talk about it. Mouth's getting dry. Florida's natural, baby. As natural as commercialized orange juice gets. At least. No takers, huh? All right. Couple ways to do it. Here's how I might do it. I might say, let's make a simpler problem. Let's make that 2 times 4.8. Now, whatever that's going to be is an easier answer to find, right? We can do that, right? 2 times 4 is 8. 2 times 0.8 is going to be 1.6, so we get 9.6. But that's going to be too big, right? We did 0.2 too many, right? That's the difference between 1.8 and 2 is 0.2, right? So we did too much, so we had to take away some. We're going to take away 0.2 of 4.8. Right? We've got double 4.8, but that's 0.2 too much, right? We wanted 1.8 times 4.8. So we have to take away 0.2 of that. So the first one we said, not too bad, right? 2 times 4 is 8. 2 times 0.8 is 1.6. So we get 9.6. And then over here, isn't it the same problem just with the decimal place here, right? We got 2 times 4.8 versus 0.2 times 0.48 or 4.8. So it's going to be the same answer, a 9 and a 6, except it's going to be one decimal place over, right? So it's 9.6 minus 0.96. We can do that. So 9.6 minus 0.96, it's like $9.60 minus 96 cents. Sounds a little tough, right? What if we take away just 90 cents first? 9.6 minus 0.9. Take away 90 cents. We've got 60 cents here. We're taking away 90, right? 60 cents goes away, but we still have to take 30 cents more, right? We took away 60 cents, and then we need to take away 30 more to make a full 90. So what I get is after I take away 30 more, I get 8.7. So what I did is I subtracted 60 cents first. That got us to 9, right? And then subtracted 30 cents more. Got me to here. I still need to subtract that last 6 cents. So what I'm going to get is 8.7. Remember, 8.7 is 8.7070 cents, right? 70 cents minus 6 cents is going to be 64 cents. 8.64. That's one way to do it. Another way to do it is maybe to round this to 5 and do math that way. You'd still end up having to take away 0.2. The reason I like this one better is because it's the same answer, just with decimal place changed. Lots of ways to do it. So 8.64. That makes sense, right? This is a little bit more than 4. That's a little bit less than 2. We should get an answer around 8. So 8.64 kilometers squared. I'll leave this last one to you. Number 9, it's the same dumb problem, right? Average the bases. Times by the height. So that's 8. Let's look at number 10. It says find the area of each regular polygon, and that's the key. Regular polygon means all the sides and all the angles are the same, right? It says leave your answer in simplest form. All right, let's take a gander at number 10. So remember, we have this thing called an apothem. And an apothem is from the center of our object, of our regular polygon, to the edge of that polygon. Okay, at 90 degrees. And what this does is it creates some right triangles. This guy right here is our side length, which we know is 12 because all the sides are the same, right? All the way around the object. So our side length is 12. And then n we say is the number of sides. Well, in this object, it looks like we have 1, 2, 3, 4, 5, 6, 7. Septagon. Well, if we find the area of this big triangle here, then we just times it by 7 and we get the area of the whole thing, right? Well, what is the area of this big triangle? Well, it's going to be base times height divided by 2. Well, we know our base is 12. Our height is 12.5. So if we do that times each other divided by 2, we get the area of the big triangle. So the area of our triangle is going to be our base, 12, times our height, 12.5, divided by 2. So that's the area of that triangle right there. Let's figure that out. We've got 12 times 12.5 divided by 2. We can do this in any order we want. What if we do 12 divided by 2 first? Well, that gets us 6. Twelve divided by 2 is 6. And then we do 6 times 12.5. Well, 6 times 12, right, that's going to be 72, because 6 times 10 is 60. 6 times 2 is 12. Add them together, we get 72. But then we also have 6 times 0.5 to add on there, right? Well, 6 times 0.5 is just half of 6. That's 3. So we get 75. So the area of the triangle is 75. Well, how many triangles will we have in this diagram? If this is one triangle right here, right? We get 1, 2, 3, 4, 5, 6, 7. The same number as we'd have sides, right? So what we do is we take the area of the triangle. We're going to times that by n, the number of sides. That's our formula. Well, the area of triangle is 75. And n is 7. Because we have 7 sides. I'm going to do 7 times 7 in my head and get 49. Now, that's really 7 times 70, right? That's what that 7 stands for, 7 tens, right? So it's 7 times 70 is 490. And then we're going to do 7 times 5 and get 35. We put those together, we get 525.
25.
$525. So what do we do here? We took the apothem as our height for our triangle and the side as our base, and we found the area of the triangle, right? We did S, the side, times the apothem, divided by 2. And then we times that by n. Another way to write that formula is n times a times S. And then divide by 2. I'll leave number 11 for you. Same problem. Let's look at number 12. So our apothem is 4 root 3. And our side length is 8. So S is going to equal 8. And we know N is the number of sides, right? Well, that's going to be 1, 2, 3, 4, 5, 6. So you've got a hexagon. And again, the key is that this is a regular hexagon, so we can find the area using the apothem. We just do N times A times S divided by 2. N is 6. A is 4 root 3. And S is 8. Well, we can divide any of these by 2 to start out, right? So let's do that. Let's do 8 divided by 2, right? Make the biggest guy smaller. So what we get is 6 times 4 root 3 times 4. It's all multiplication, so we can do it in any order we want. We've got 4 times 4, which is 16, and then we can times that by 6. That's going to be 96. Or you could do 6 times 4 and get 24. 24 times 4 is going to be 96. And then times root 3 is this. So we have 96 times root 3. That's not going to come out to a nice number if you plug that into your calculator, right? Root 3 is an irrational number. It goes on forever with no pattern. So it's going to get us a weird decimal that we're going to have to round, right? So here's my opinion on that. If you have to round, and it's a really weird decimal, just leave it like this. That's 100% correct, no rounding involved, and it's less work, right? I didn't have to grab a calculator to do it. I just did 6 times 4 times 4, and then times root 3. How we feeling? What's up, Eads? Because that's it, guys. Send out the quiz today. Can't review and give you the quiz on the same day. Sorry, bud. I will give it to you tomorrow. Would you guys rather... What do you want to do? The original plan was review, then quiz. Review, then quiz. Review, then quiz, right? What if we did review and then quiz tomorrow? Would you like to review tomorrow as well? So here's what I'm saying. Maybe it would help if I drew it out. Maybe it would be obnoxious if I drew it out. I don't know. So today is Tuesday all day. Right? We got Tuesday, Wednesday, Thursday, Friday. So our original plan was review part 1 today, which we did. And then quiz part 1 tomorrow. No class, right? Review part 2 on Thursday, and then take quiz part 2 on Friday. Would you rather do that, or would you rather bump all these things back? So alternate plan is same thing we did today, right? and review part 2. Ooh, actually, maybe that wouldn't work. I think some of you guys are going to take the quiz during class time, right? Forget it. No quiz, or no class tomorrow. Just quiz part 1 tomorrow. We'll do that, okay? And I'll be here to ask questions and help. That's fine. We'll keep it normal. I was thinking we could double up and move things up earlier, give you a Friday off, but I don't think it'll work. So this is the plan. So we checked this off today. Tomorrow we'll take quiz part 1. That's just what we just reviewed, right? Part 2 will be trig. It may or may not also include explaining why this formula is what it is, right? You can think of it as area of the triangle times the number of sides, or you can think of it as perimeter times apothem divided by 2. Honestly, I like area of the triangle times number of sides better. But either way, it might include an explanation of that. I haven't decided yet for part 2. But that's the deal. Do you guys want to go over any of the other ones? Because if not, I'll let you go early. In fact, if you're good personally, you can take off. But if anyone else wants to stick around for help, we can do that. It's up to you. How are we feeling? I feel like this is very doable. The only downside is that it's been a while since we've talked about this stuff, but hopefully this review has refreshed your memory. Sorry if you're being sick, everybody. Weather's supposed to stabilize this week, so that's good. And I'm working on cutting down on the bright lights in my house. Trying to find a way to make this work. Keep my sinuses clear. So what do you guys think? Let out early? See you guys later? Tucker, all I'm worried about is you have the majority of your assignments in, right? And that you've taken and completed all my quizzes. Like you got a passing grade on all my quizzes. But I will have more information about that later in the week just to make sure that you're good to go. Remember, next week we don't have any class, but you can complete homework assignments. I believe grades are due next Friday for me. So you should be good to go. Also, I've heard that other teachers have been uploading grades to not Classroom, but Skyward. I'll start transferring those over so you can see where you're at. Because honestly, your grades can only go up. The only issue you have to worry about is completing the class, which for me, for this class, is all quizzes and most of your assignments, so over 50% of the assignments. And if you've done over 50, you're fine. I know it's been a little weird. The way I've gone about it is that if you have 100% on your assignments, I just didn't put in a grade at all in Classroom. You just said you turned it in, and then I said, okay, great, we're good. I can put in 10s if you want. I can also I'm going to throw it in Skyward too. I know that's been confusing for some people, and I apologize for that. My thought was, why take the time to plug the grade in if it's already perfect? Your grades can only go up. But I understand why that can be nerve-wracking for some of you guys. I don't want you guys to stress. But yeah, Tucker, you should be fine. Everyone that's been here and taken the quizzes, like if you know you've taken the quiz, right, then you should be fine. But I'll get that information out to you guys as soon as possible. I'm sorry for making you guys stress about that. I didn't realize other teachers were throwing stuff in Skyward. Because I'm a big dummy. But yeah, that's it. So I'm going to take off, let you guys out early, and I'll be back at 1 o'clock for regular geometry.